RoboPapa.
Hey YouTubers, RoboPapa here. Today's is the second video out of 3 of how to use Arduino with some sensors and shields. I will post a link to my first video in case that you missed that down below in the description. But today's video we're going to continue on and use what we built on the first video. So we will use Adafruit's motor shield, which obviously I got at Adafruit, and really that motor shields allows you to use 4 stepper motors, 4 DC motors or 2 stepper motors, as well as 2 servo motors. Originally the shield comes with the pins straight up, but I modified that to use the angular pins. That way if you're stacking those, you can actually connect the servers from the side. And as in the first video, we will use the same ultrasonic sensor, which is the HCSR04, to detect basically the distance. I also, because I'm using a metal chassis over here of the tank, which I can post the link to buy it from SparkFun, I built like a small 3D, I printed a small base for it with some 3 pegs over here that can connect, let me zoom in, that can connect to the there we go. They can connect the Arduino over here with the Arduino holes, and that way you can hold it in place. So now the Arduino will be safe from any metal contact on the bottom. So I already have it connected over here, and I'm going to use my power supply because the motors over here needs a lot of voltage. So I will run it on 10 volts, and I wrote a sketch already that's basically looking for the distance, and according to the distance it will either move forward at a certain speed or stop if it's at a certain distance, or move backwards. So let's run it, and it probably immediately will start running. So I'll put my hand over here, that way it can stop. Then as we move closer to the ping, you can see that it's actually moving backwards with a small speed. And then as I'm moving closer, it's actually moving faster. So now if I'll move back again until it stops, and then as I move further away from it, it will start moving forward, all the way to basically full speed. And the idea behind that is if we have two of these and they're detecting an obstacle or a wall, depending on which one it is, it will actually either move slower, and therefore the shield, the tank will start rotating towards that direction or away from that direction. And if it's too close, it will actually start moving backwards, which means it will turn in place. So we can look now at the code and see how we did that. Alright, so let's look at the code that we had to run it. Obviously I'm using the liquid crystal library, as well as the Adafruit motor shield version 2 to control our shields. As you saw in my first video, I have the ping library that I created. So one thing that I needed to know is what kind of direction and speed do I need. So I created a structure that's called motor shield, and we use it in the bottom function. Initially we're using 1 ping right now, but obviously as we get closer to the end, which will be next video, we'll have 2 pings. The first ping is going to use 10 and 7. It's the trigger and the echo, and then if we want inches or centimeters. The typical liquid crystal, nothing to explain there. And then I'm creating a shield object, and therefore after that getting 2 more motors that are actually motor 2 and 3 on the Adafruit motor shield. I created a function that gets motor speed, and it's returning me that structure. In the setup, we setting up 2 motors, even though I'm using only 1 for now. and then I'm printing out some text to the liquid crystal. I'm calculating the distance of the ping by actually calling the distance function, and for now I'm just limiting it from 1 inch to 40 inches, even though it can actually see 140 inches. And so that's the constraint. So no matter what the distance is, even if it's 140, it will still fall under 40. And I'm outputting some information to the liquid crystal, that way I can see what I'm dealing with. Then I'm calling this function, which we'll review in a second, but that one gets me the structure that we looked over here, that returns me the speed and direction, and that's what I'm setting up for the motor, the direction, and setting up the speed, and then I'm doing a delay of 50 milliseconds. The get motor speed is really where all the heart of that motor, how it moves, really looks at the distance, and depending on how far it is from that obstacle, that's the direction and the speed that it will use. So for example, if we are greater or equal to 30, really our distance, because I know that I constrained it to 40, I'm looking to map 30 to 40 to 125 to 255, then that will give me the speed, and obviously the direction is forward. If the distance is 22, greater than 22, so obviously it's less than 30 already, because otherwise we will get here. If it's less than or equal to 22, we still want to move forward, but in a smaller speed. And then the mapping will do that for 22 to 29 is really mapped to 70 to 127. And that's where I will need to tweak a little bit, as you saw in the video, that it's a little bit jittery. Obviously the sensor is kind of like jumping with the ping, like how far it is. So I still need to play a little bit with the distance, and maybe probably add like a capacitor or something, just to avoid the noise that comes from the motors, or something like that. But that's basically the idea. I'm giving it distance, and according to the distance, that's how fast and what direction it actually will move. This one is basically if it's less than 15 and greater and equal to 8, so between 8 and 15, I want it actually to brake. So the direction will be brake and the speed will be 0. And then otherwise, if it's between 4 and 8, I want to move backwards but not as fast. And then if it's actually less than 4, which means it's really close to the wall or the obstacle, I want to move backwards and use the speed 200. So if we think about it, we have two motors, left and right, and we have ping left and right. The left ping will determine what direction and speed the right motor will move, and the right ping will determine what direction and speed the left motor will move. And the reason is because we want to make a turn. If the obstacle is on the right, we want the left motor to move slower than the right one. That way you can actually turn away from the obstacle. So that's basically the sketch. I will post it also on the website. I will put a link at the bottom. That way you can look at that. And please like and subscribe. It's really helpful. And let me know that you guys actually like what I'm doing. And the next video will be about putting it all together and showing you a small demo about it. Okay guys, thank you.